Hello everybody and welcome to the first video in our linear function series. Today's topic will be slope. Let's begin by looking at some basics of slope. The slope of a line is the steepness of that line. So the steeper a line is, the more slope that line has. Also, we use the variable m to represent the slope of the line. Slope and rate of change are the same idea. Slope has no units though, where rate of change has units. So you can see in my example here, we could say our slope is 5, while we would look at the same line and we'd interpret its axes and we'd say that the rate of change is 5 kilometers per hour. So if you understand rate of change, you're going to understand slope. There are 4 types of slope or categories. The first 2 are positive and negative slopes. A positive slope rises left to right. So here we'd say our slope is positive. And it doesn't have to be rising too much, so this is still rising left to right. So I'd still say this had a positive slope. Negative slope falls left to right. So we could say here our slope is negative, and again it could be a really fast decrease or fall, or it can be a slower one, but as long as it's falling from left to right, it's negative. The next 2 are infinite slopes and zero slopes. An infinite slope is a vertical line. It's so steep we can't measure it. So in that case, we just write it like that, our infinity sign. Zero slope is the exact opposite of that. It has no steepness to it. So that would be a horizontal line, and we'd say our slope is 0. So infinite, it is as steep as you can get, which is just infinitely, we can't even measure it, it's so big. Where 0, there is no steepness. Let's look at the slope formula. So slope, or m, is equal to the change in y over the change in x. Typically, we write it like this, where m equals rise over run. So by rise, we mean the change in y, and run, we mean change in x. Let's look at how to use this slope formula. All right, so you can notice in my example here, my picture, my Cartesian plane, I have a bunch of different line segments. So we're going to determine the slopes of these lines. So the first one we want to look at is AB. So here's A, here's B. I want to look at this slope. So the way I can measure this, or sorry, write this notation-wise, is M subscript AB, so you know which slope I'm talking about. And again, that's going to be rise over run. All right, so when we're doing this, we always want to work from the leftmost line, or sorry, point. So that means I'm going to start at A. And I'm going to go, I want to know how much, what is the change in the vertical from A to B. So I want to see how much we go up. So 1, 2, 3, 4, 5, 6. We had 6 positive movements, sorry. So that's going to be just 6 over, and then whatever our run is. So the run is the change in the horizontal distance from A to B. So I want to start right here again. This is my A, or my A line, and I go over 1, 2, 3. So it's a movement of positive 3. Once I have those values, I go 6 divided by 3 is 2. So my slope for this line segment AB is 2. I can put AB down there. All right, that's our first one. Let's look at another one. So slope of, let's look at CD. So I'll make this yellow. This is C, this is D. Once again, I want to start on my leftmost point every single time, everybody. So let's put my notation down here. Rise over run. And sorry if that gets to be a bit too much, my how much writing's on there. Fortunately, I can erase just a little bit with the program I'm using. I'll erase the whole screen. All right, maybe I'll use a different color instead of red here. So I wanted to count my movements from my vertical movement from C to D. I want to see, well, what's the difference between the level of just between C and D. So you can see here, to get from C's level to D's level, I have to actually go down 4 units. So then my rise was a -4. Now for run, I begin where I left off. I want to see how many units over I have to move. So 1, 2, 3, 4, 5, 6. So that would be 6. And then now last time we were able to divide it out, and this time we can just reduce, and that's fine. So negative 2 over 3 would be the slope for this line segment CD. Okay, let's look at FG. So our third one, slope of FG. Rise over run. Okay, again now, so you might be wondering, where's FG? F is right here. G is right here. Not too much. We want color again. So I want to see, well, vertically, is there any change? And you can see it's on the same level. So no, there's zero change in the rise, a change in the vertical. For run, let's see how much we have to move from one point to get to the other. So 0, 1, 2, 3, 4, 5, 6. 0 over 6. What does 0 over 6 equals? It equals 0. So we have 0 slope for this line. And like we went over previously, that must mean it's a horizontal line. And if you look at FG, it is most definitely a horizontal line. Let's look at our final slope, HI. Rise over run. Okay, in case you're looking for that one, we'll use light blue here. There's H, there's I, and the one thing you might notice right away is, well, which is the leftmost point? Well, seeing there's tied, or it's tied, you can't go wrong, so we'll just choose H here. And let's look at how much change vertically there is. Okay, so it looks like I have to go down a bit. 1, 2, 3, 4, 5, 6, 7, 8. So I went down 8, negative 8. Now the run. How much does this run? How much do we change side to side from H to I? And you can see we don't move at all side to side. So it would be 0 there. Negative 8 divided by 0. Well, that is undefined. We can't divide by 0. Or we can call it infinite in this case. So that category with the vertical line, it can be called infinite or undefined slope. Perfect. So hopefully that made some sense on how to use that formula. Okay, in this example, let's draw a line segment with a given slope. Meaning, I want to draw a line that has a certain slope to it. So if we look at A, we can see here the slope has to be 2. Okay, and that's all the information we have. So really, we don't have too much information. We could draw this line with a slope of 2 a bunch of different ways. The first thing you should understand about slope is it can be seen as direction between 2 points. So it's like kind of like if you start at one point, how to get to the next point. So if I just choose a random point down here, I can then get to the next point using my slope of 2. Now when I do this, I want to interpret my 2 as the rise of a run. So I want to think 2 over 1. And again, this is so this is telling me to rise 2, 1, 2, and run 1, 1 to get to the next point. Once I have 2 points, I can then draw a straight line through them. I'm sorry my line isn't too straight. My ruler, it doesn't really respond well to my tablet, so we're just going to go freehand there. Now, that's one example. And again, like I said, I could draw this anywhere. So if I put my starting point right here, I would then follow the slope. It says go up 2 over 1. That would get to my second point. And then I draw this. So in your assignments, quizzes, or tests, if you ever have a question like this, don't worry that there's only one way to draw it. There's multiple ways to draw it. All right, let's look at B. So in B, my slope is negative 4 over 3. It's already in fraction form. Now, when I have a negative, I always include it with my top number. You don't have to. You can include it with the bottom number. Just if you're working with the left to right kind of notion, it makes most sense. So again, I'm just going to start out by picking a point. Now, I'm going to use a little bit of reason here, though. I know that's a negative slope, so I know my slope should drop left to right. So that means I don't want to really pick a point, say, down here, because then I'm going to go off my Cartesian plane. So it's not that it's wrong, it's just going to be more difficult to draw. So I'd rather pick something that I know is going to fit. So I'm going to stick to the second quadrant. Now, remember, the names of the quadrants go like this, 1, 2, 3, 4. So I'm going to stick to something in the second quadrant, and the point and the point can kind of go anywhere. I kind of stumbled because you can see here that some of my horizontal lines didn't show up very well, did they? So let's just hope that I'm kind of on negative 2. So I'm at negative 3, positive 2 there. It's telling me now to go down 4, 1, 2, 3, 4, and then over 3, 1, 2, 3. That'd be my second point, and I can draw my line through it. Again, I could do it wherever I want to do this. So let's say I tried it here next time, or just for another example, down 4, 1, 2, 3, 4, over 3, 1, 2, 3. There we go. So again, you've got versatility. There's not just one right answer. Okay, C, our final one, 7 over 4. I know that's going to be positive, so meaning I'd rather pick something kind of in this quadrant here. So I'll just pick something right here. It's telling me to go up 7. 1, 2, 3, 4, 5, 6, 7. And then over 4. 1, 2, 3, 4. So that's my second point right there. And again, sorry about those horizontal lines. Why they didn't come in when I brought these graphs in, I'm not sure. But I think you get the point. So once again, I could draw that another way. I won't. I think just one line is good enough. But hopefully you see that there is more than one way to draw these lines. Example 3. Determine the slope given 2 points from a line. So thus far, you guys know one formula for slope, which is slope equals rise over run. That is great, and that's you want to use that formula when you have a picture. So when we have m equals rise over run, that is good when you have a picture. So if you have a picture of the line, that would be the formula to use. There is a second formula, however. The second formula is really, it's the exact same thing. It's just what we'd use if we don't have a picture. So we remember we want to find, we said rise was really the change in y, and we said run was the change in x. So we can even draw that out a little bit more. To determine the change in something, we can go y2 minus y1, x2 minus x1, and what that really means is I'm finding the difference between the two y coordinates, then I'm going to find the difference between the two x coordinates. All right, so we would use this when you have points. Another way of looking at it, no picture. So if you have a picture, use rise over run. If you don't have a picture, use this one I've just presented to you. All right, so you can see here in A, I have 2 points. So I'll write m equals y2 minus y1, because that's going to find the difference between the change in y, x2 minus x1. Now, where are these y2s and y1s and all that kind of stuff? Well, the 1s refer to the first point and the 2s refer to the second point, meaning this would be x1, this would be y1, because it's from the first point. This would be called x2, this would be called y2. All right, so once you know that, now it's just plug it in and work it out. So I'll use some open brackets here. I like to do that so I don't use any sign. So y2 is negative 3. Done it. y1 is 1. x2 is 2. And x1 is negative 1. All right, you can see here I have a sign to you. I want to make sure I don't mess it up. Negative 3 subtract 1 is negative 4. 2 plus 1 is 3. Here's my slope, negative 4 over 3. So you don't need the picture of a line to determine the slope. You can use the points. If you really wanted to, you could plot the points and then use rise over run, but that's a lot of extra work. It's easier just to use this new version, which is accomplishing the same thing. We're still finding the rise. This is the rise, the change in y. Can't spell, sorry guys. This is the run, which is the change in x. So change in y, change in x. I want to make sure you don't think they're two different formulas. They're the same formula. They're just different ways at accomplishing it. All right, let's look at the second one. M equals y2 minus y1 over x2 minus x1. And in my head, if I don't have a picture, I know to go to this other formula. I forgot to give it a name. This thing has a name. This is simply called the 2-point slope formula. You could be thinking, well, what do you call the other one? Well, we really just call it rise over run. So we don't really have a great name for the first formula, but the second formula, 2-point slope formula. All right, so now again, the y2s and all that stuff. Okay, so then this would be x1 because it's the first point, y1 because it's from the first point, x2 because it's the second point, y2. Use my open brackets. Again, this just helps not miss sign changes. Maybe I'll use red here so it stands out a bit. Y2 is 1. Used it. I'm sorry. Yeah, sorry. Y1 is 3. Sorry, guys. I kind of lost track of myself on the page. X2 is 2. X1 is -3. And it just so happens that we have another sign change on the bottom. I don't want you to read into a pattern. There's not always a sign change on the bottom. It can be on the top or bottom, or there might be neither. Or there could be a sign change on both top and bottom. Just whatever happens, happens. It's all good. All right, so 1 minus 3 is -2. 2 plus 3 is 5, and then that is my slope, -2 over 5. Let's do one last one. So again, I like to just write this down each time. If you don't like that, if you want to go straight into I'm presenting a video, so I'm not going to skip any steps. X1, Y1, X2, Y2. Use my open brackets. Again, you don't have to do that either. That's just something I like to do when I'm presenting it to people. Trying to clean some things up. So let's go to a different color again. 3, Y1 is -2, X2 is 4, and X1 is 4. So I see, actually, I have a sign change. That's a plus. So then I'm going to get 3 over 2 is 5. 4 minus 4 is 0. You can't divide by 0. So then I know my slope must be infinite. Now, if it's infinite, that means you have a vertical line, everybody. And if you check out the point, you can see your x-coordinate is the same. So that is a tell. If you have coordinates that are same, in this case your x, that means that actually this is a vertical line where x equals 4. If you were to have a set of 2 points where the y values are the same, that would just mean it's a vertical line, and it'd be y equals whatever the repeating number is. So you can kind of watch for that, but if you don't pick it up, the slope will tell you it as well. All right, our final example. Let's interpret a slope given a graph. So Ashley has a part-time job. She recorded the hours she worked and her pay for 3 different days. A, what is the slope of the line through these points? Okay, so you can see that there isn't a line. So if there's not a line, we'll just draw it ourselves. Holy, I'm not using a ruler, people. That was pretty darn straight. Okay, so now I have 1, 2, 3, 4 different points that I could actually choose from. It doesn't matter. This is just like rate of change where you could choose any 2 points from the line. Slope and rate of change are the same idea. So same here. I can choose any 2 lines that I want. Any 2 points. So typically I like to use the easiest points I can. So I'll just use the first 2. And remember, we want to start on the leftmost. Now, what does leftmost mean? It means the point furthest to the left. Furthest to the left. Okay, so I'm going to start with that one. Now, I'm going to look at, I guess, m equals. Now, I have a picture, right? I have a visual, so I'm going to use rise over run. If I didn't have that picture, I would use the 2-point slope. So the rise, it looks like 2. But don't just write 2. You got to actually see what each tick mark is worth on your axes. And I can see here that each tick mark is 18. So instead of just 2, I've actually done 6. And then my run, 1, 2. Let's just double check though before I write 2 down. Is every tick mark, or what is the scale for this axis? And it's going up by 1, so it actually is just 2. So 18. The slope of the line is 18. What does the slope of the line represent? Well, this is where we're starting to get into rate of change. So really, if we interpret it as a rate of change, what would it be? Well, this 18 would be, you can see that the pay is dollars, so it would be $18 per hour. All right, $18 per hour. Use the answer of B to determine how much she gets paid for 3 3/4 hours. Well, we need to remember, we need to remember that our slope was 18. The rate of change was 18 bucks per hour. So use this answer to determine how much he gets paid for 3 3/4 hours. There's different ways to do this, you guys. However you really want to do it. If you know what she gets paid for 1 hour, we could just multiply by the 3 3/4 hour. We could also use a proportion. So really, it's up to you. A lot of students do it just straight multiplication. Now, if you know it's $18 per hour, 18 times the amount of hours, 3.75. If you convert 3/4 to decimal, works out to $67.50. The other way to do it is if we use more of a rate of change, I could say that it was $18 for every 1 hour, and I'm going to create a proportion. I'm wondering how much money she'll make over 3.75 hours. Okay, and then I love proportions. So if you didn't think of, if you weren't able to make the connection right here, what to do, then maybe you're a person who likes proportions. Proportions are great because they actually do the thinking for you. It sets up the logic for you. So what I do is I always bring my, I'm going to cross multiply, sorry, and I always bring my x to the left side. So I'm going to x times 1. That's going to equal, oh, sorry, equal sign. That's going to equal x. Now, when you do this, by the way, do not take the units with you. So I'm just going to cross those out. And then I'll do the other cross multiplication. And you can see there, oh, I'm trying to get the right color here, people. That's 18 times 3.75 again. So the math, or sorry, the proportion aligned the logic for you, and it made you do the right calculation. So proportions are nice. If you know how to set them up, they will figure out the logic for you. D, answer the, again, you're going to use that answer from B to determine how long it takes for Ashley to make $81. Okay, so let's try that. Seeing we just talked about a proportion, let's see if we can do that again. So for proportion, you start off with a math fact always. So our math fact is that this person makes $18 every 1 hour. We want to know how long it takes to make $81. So I know $81, but I don't know the amount of hours. So I'm going to put an X in the hours. Once I have that set up, I just cross multiply and solve. Remember I said when I cross multiply, I always bring my variable to the left side. So it's going to be x times 18, which is 18 equals. And then now I do the other cross multiplication. 1 times 81. Remember, I'm not using the dollars and the hours in my calculation. I use that to set it up. So you can see my fraction here was always money over hours. And that was on both sides. So I use the units to help set it up, but then I don't use them in the calculation. All right, so I'll keep going here. Sorry, I'm fighting hiccups. You can likely hear that in my voice. Now I'll just divide by whatever is in front of the variable. So 81 divided by 18. Put it over here. X equals 4.5. And again, that was what we're looking for was hours. So 4.5 hours. So that was the proportion way. The other way you might have already thought, well, if she wants to make $81 an hour and she gets paid by paid $18 an hour, you just go 81 divided by 18, and then that will work out to be 4.5. So you don't have to use a proportion, but if you have trouble thinking about the logic, like what do I do, multiply, divide, I'm kind of lost, then just use a proportion. If you're a person who can handle that type of thought easily, then I would not use a proportion until I really need to. All right, so that is everything I got for you. If it didn't make sense, go talk to your teacher or come find myself. Have a great night, everybody.